Welcome to the advanced look looking at factoring the difference of squares and perfect square trinomials. So again, the first question says to factor fully if possible, and if it says fully, the key word here is fully. Fully, oopsies, means it implies that there's going to be, you have to factor using multiple factoring techniques. Okay, you may have to, so we'll have to watch out for that. And this other, oops, I skipped another portion. If possible, implies that there might be questions that aren't factorable. You can't break them down into factors. So let's be aware of that when we take a look at these three questions. X squared plus 16. Again, this looks like two terms, and both terms are perfect squares. So to me, a difference of squares comes to mind. So it satisfies the fact that they're perfect squares. It satisfies the fact that there's only two terms. But is it a difference of squares, right? And right here, this is not a difference. This is a sum of two squares. That means we cannot. Okay, so going by the definition, not possible. Because it's a sum of squares. Sum of squares. Okay, now if we were to try to do it with x plus 4 and x minus 4, pretending it is a difference of squares, you can see that this last term here, positive 4 times negative 4, gives us negative 16. We can't get that positive 16. If we try to get that positive 16 by putting plus signs here, if I were to expand this, that's going to double. It's going to give us x squared plus 8x plus 16, because we are going to get 4x and 4x, which will give us the 8x there. So this is not possible. I'm going to erase all this, but it's important to see that it's not possible. Okay? And maybe I'll just leave it for now. Okay. Right here, this looks complicated for some because some of us are fractionists and they start fearing what they don't understand. But just break this down and you can understand it easier. Okay, just look at closer, look and break it down. So by breaking it down, I look at one. Is this? I see two terms here actually, looking over there, and this is indeed a difference of two terms. Now the question is this a difference of squares? So let's take a look here. X squared is a perfect square, and y squared is a perfect square. So that's good. I'm going to break this down. Is 1 a perfect square? Yes. Is 16 a perfect square? Yes. So that means everything here is a perfect square. Take a look over here. 16 again, perfect square. 25 we know is a perfect square. That means yes, this indeed is a difference of squares. So we are happy. So now we can apply what we learned about difference of squares. We set up our two binomials. Let's get a thicker pen here. And take the square root of each. So what's the square root of 1? 1. What's the square root of 16? 4. What's the square root of x squared? X. 1. And then we write this out over here. Because 1 over 4x times 1 over 4x, if we multiply them together, will give us 1 over 16x squared. That's good news. Now we take the square root of the second term. Square root of 16 is going to be 4. Square root of 25 will be 5. Square root of y squared will just be y. And we write that over here. And we know that 4 over 5y times 4 over 5y will give us 16 over 25y squared. And again, there's no middle term here. And they have to multiply to a negative number. So they have to be different signs. And again, this can be minus, and this can be plus, or this can be plus and this can be minus. Either way, we'll get you full marks. And now we double check to see if we can factor anything else. Nope. Okay. We're done. And here, what we have here looks quite complicated. But really, remember there's brackets here. So if you treat this as one number squared minus one number or term here squared, this is considered a difference of squares because, again, there's this difference here of two perfect squares. Even though x itself is not a square, 2 itself is not a square, these brackets themselves actually group them as one thing. and say, is this whole thing a perfect square? Indeed it is, because the whole thing is being squared. Y itself is not a square. 5 itself is not a perfect square. But because it's bracketed and the whole thing is squared, that means this whole thing is a perfect square. So this is actually a difference of squares. And again, because it's a difference of squares, we can actually apply our factoring technique to this. We write out brackets, and we might need I'm going to bring out big square brackets to differentiate. What is the square root of x minus 2 squared? If I take the square root of that, remember the opposite of a square is a square root. So if I square root this, the square disappears. So this is just going to be x minus 2. That is the square root of x minus 2 squared. That's going to appear here. And that makes sense. If I were to start foiling this, x minus 2 times x minus 2 will give me x minus 2 all squared. Likewise, if I'm going to write the square root of y plus 5 all squared. If I square root y plus 5 all squared, it's just going to be y plus 5. And I'm going to write it out over here as well. And let's double check when we FOIL this out or expand. If we do y plus 5 or multiply y plus 5 times y plus 5, it's going to give us y plus 5 all squared. And again, there's no middle term here, so again, we're going to have a plus and a minus inside there. Okay? So we have factored it because we have two things that are multiplying each other. Okay? But what we can do within the one bracket, we can actually simplify a little bit, and we should. So if I ignore this bracket over here and just focus on this itself, can I simplify anything in here? We certainly can. Okay? So I'm going to write those big square brackets there. And we're going to have x, I'm going to have a plus y, and I'm going to collect like terms. Minus 2 plus 5. What's minus 2 plus 5? That'll be plus 3. Multiply by this second set of brackets here. So I'm going to simplify what is happening inside here. Okay, and we have to be a little bit more careful with this one because this is subtracting. So we're subtracting. I'm going to distribute this negative sign over first. So this will be x minus 2. We can drop the brackets there. Minus, we can just drop out the brackets. We got to subtract everything inside or distribute that invisible negative 1 to both. So this will be minus y and minus 5. Let's thicken the pen here. And this is as simplified as possible, so I'm going to let this relax. This we can now simplify. So x minus y, and negative 2 minus 5 will be minus 7. Okay,